Hey everybody, welcome to the binomial distribution video. And for the binomial distribution, we're going to be looking at an event that has a probability of success and obviously a probability of failure. And that's going to be it, just success or failure. We notice in this example, these are going to add up to 1. And we're going to have a number of trials. And for this, we're going to have, we're going to be able to calculate the chances of X amount of successes in N trials. And to do this, I think it's best to look at an example. So here I have a little game that drops balls. It's kind of like The Price is Right. Do you remember that Plinko game where they drop the balls and then they have different prize amounts on the bottom? And that's what this is going to simulate doing. So I can go ahead and make this just one little piece, and it's 50-50 right now, falling either way. And as we go through this, we can see how the probabilities. Oh, it's actually kind of slanted a little bit on this side, but we'll see over time if it comes back to be about 50-50. You can see the average here is 0.5, and I could put the ideal on. The ideal is in the little blue. It's kind of hard to see, but it shows equivalent. We'll let it run a little bit more. Let's see if this catches up closer to 0.5 and 0.5. So this is showing how the law of large numbers works. Ooh, well, it really dropped there. Come on, right side, catch up there. Catches up a little bit. Oh, there we go. The law of large numbers is helping us out. We're getting pretty close to even. Look at that. Whoa, really caught up. Oh, too much now. Okay, but you see how that will work out in the long run. Oh no. Well, it will alternate back and forth. So we can go ahead and change this. Here's 2 rows. And you can see how the balls are going to fall. To fall on the right-hand side, it's going to be a half chance and a half chance. So a quarter of the time will fall over here. To go here, it's a half chance. So a quarter of the time we fall over here. And then to fall towards the middle, that would be a half chance this way, half chance this way. So that's a quarter. Or a half chance this way, half chance this way, which is a quarter. And a quarter plus a quarter takes us to a half. And that's how we can see how these probabilities are coming into play. We can take this larger. And if I expand this all the way out to a big one, maybe I'll go even further out. We'll hopefully start to see what's known as a binomial distribution come into play. And what's going to happen is it's going to be really hard to get all the way out to the edge, because to get out to the edge, you need to go to the right side, right. You know, what is that, 10 times? So 1/2 to the 10th power. But to land in the middle, that would be an equal amount of lefts and rights. There's a lot of ways to do it. You know, you can come over here and then come down there. Or you can see a lot of the balls are clustered in the middle, because it's it's hard to go left a bunch of times, or it's hard to go right a bunch of times. Oh, there we go. Oh, almost. Whoa, a few made it over there. Oh, one made it all the way over here. And then you can start to see that distribution showing up. And I can put the ideal on. Wow, we're really close to the ideal already. I can go ahead and restart this, and we can slant them. You can kind of see how they're all shifting. What if we have an 80% chance? Let's see if we pump this up to 26. Whoops, no, that's kind of boring, just one. So now this is maybe like shooting free throws. If you have an 80% chance to make a free throw, how many do you make out of 26 shots? So you're going to make a lot of those shots, right? If you have an 80% chance, it's hard to make no shots. But it's hard to make all 26 shots too. That's 0.8 to the 26th power. So there we go. We get to see all those scenarios falling down. There's our ideal. Pretty close match. Okay. All right, so this is going to be an example of binomial probabilities. Perhaps I'll link this applet in our agenda. It's kind of cool. Let me go back here. So we have some calculations here. The average, if we go to, let me go to this free throw example. If we were taking 26 free throws with a 0.8 chance of success, what we do is we multiply that 26 times the 0.8. So on average, we're going to make about 20.8 free throws. There's the average right down the middle, 20.8. And so to calculate the average, you just take the amount of trials multiplied by the chance for success. That's what this is showing us here, the amount of trials multiplied by the chance of success. And we have different ways to calculate the variance and the standard deviation. We're not going to use those too much, but they're good to know. And here's the individual binomial calculation, which we won't really be getting into too much. Here it breaks down. We don't need to focus on this too much. All right, so let's look at another example. Fair coin is flipped 15 times. Each flip is independent. What's the probability of getting more than 10 heads? And so let x be the number of heads and 15 flips of the fair coin. And so we know we have a 50% chance of success, 50% chance of failure, and 15 trials. So the probability, we want to calculate the probability of x bigger than 10. Okay. And here's the notation for the binomial distribution. We use a capital B, where n is the amount of trials, and p is the chance of success. So let's do this coin flipping example. So 15 flips, and we want 10. We want to calculate 10 or more heads, 10 heads, less than 10 heads. Let's maybe go back to the kind of like the Plinko example. So 15 times helps us really visualize what's going on. And we want to have 50% chance of success. And we're doing this for 15 times. Okay. So we can let this run. And so down on this side, we'll assume heads is over here and tails is over here. So this side would be 15 heads in a row. This side would be 15 tails in a row. I'll just let that run. Let's see if it runs in the background. Nope, I don't think it does. What are we at? 130. So more than 10 heads. That will be our first one. Nope, it doesn't run in the background. Okay. So more than 10 heads would be here, 11, 12, 13, and so on. So we can watch this run, and it's hard to get more than 10 heads. It's per kind of 10 is common, 11 is common, but wow, it looks like 12, 13, and beyond are hard. Put the ideal on. So instead of running the simulator, we probably want to learn how to calculate these. And so to calculate these, what we're going to do is go to the binomial distribution calculator. And I linked this in our agenda. And we can use our graphing calculator for this as well. Probability of success, so for our coin flipping example, 0.5, 15 trials, and we're looking for 10 successes. So we go down here and we calculate. And I copied those into my sheet right here. And so I can summarize these. So the probability of more than 10 heads. So here our lowercase x, that's our number of successes here, 10. And so when it says x equals 10, that's going to be when we're right on 10 successes. So the chance for 10 successes is right there, about 0.09, so 9%. The chances that we're less than that 10, pretty common, 0.849. So if we think about our Plinko example, it was common to be to the left of that 10 spot. Less than or equal to that 10, slightly bigger because that includes the 10. And the chances of being bigger than the 10, 0.059. So our first answer, probability of being more than 10, that would be the 0.05923. The probability of 10 heads, that's going to equal or 0.0916. Probability of less than 10 heads is going to be this one right here, 0.849. The expected number of heads to occur on average. So for that, we take the number of trials multiplied by the chance for success, and we get 7.5. So I think I will pause the video here and we'll look at another example next.